All right, everybody, here's lesson 7.2 on amplitude. First, I want to start with the standard form of our trigonometric function. So we have y equals, and I'm going to use my colors like I like to for each part. For A, and sine, as like I said before, everything with trig functions, they always use sine. It's called a sinusoid. B, I'll talk about each of these letters as we go along. X minus RC. Let me close that, and we have a plus D. So throughout this whole thing, I'll be trying to use these certain colors to kind of stick to make sure we're looking at the same thing. So we're going to use our graphing calculator, and we're going to graph these equations on our calculator. So I'm going to pause. Well, I want to make sure you know how to do that first. Everybody should have done that by now, but just in case we need to remember. So, okay, so when you do that, you're going to go to y equals, and you're going to type in the function. We're going to type in y equals, and sine is right here. X, I highly recommend that you get used to closing that parentheses because it's going to look so different if you don't, okay? We're going to do things, especially with that C up there, and if you don't do it right, you're going to graph something that's incorrect. So we graph that. Again, we're window. Here's our window, and we're going from, our window will be the right there from 0. So go to window, which is right here next to y equals. We're going to go from 0 and then 2 pi. Now remember, you can just go hit second button, put the 2, second button, and the pi key is right there above the division sign on the caret key symbol. Hit enter. And we're going to divide by, we're counting by pi over 2. So instead of counting by ones on the x-axis, we're going to do that by pi over 2. So we hit pi divided by 2. And it'll change it automatically again, like I said before, in a decimal. And then we're going to do our minimum, our range will be -3 to +3. And we're just going to go by 1. So again, our domain is our x values. So that's from 0 to 2 pi, and our range is from -3 to 3. That's the y values. Okay, so when you hit graph, there you see it. And then you kind of see how it goes up, like we talked about on 7.1, all the different points on there. And so when we use this kind of graph, that's the sine one. So now on the same scale, okay, on the same axis, I should say, we're going to go back to y equals, and this time we're going to go down to the next one, and this time we're going to print, type in 2 sine x. Oops, sorry, I did the wrong one. Should be sine x. And hit enter. And I'm going to go ahead and type in 3 sine x, the next one. And when I hit the graph, I can see all 3 of them, and look what happens when we do that, okay? So hopefully you notice that when you do the sine x, it goes up to 1. That's the blue one. When it goes to cosine x, it goes to, so when you look in here, here's the cosine x is right here. So our range is 1 to -1. And then the other one goes up to the 2 sine x, this red one here. And then the top one goes up to this very top up here too. It looks like the 3, down to 3. So we're going to do this, and we're going to sketch that onto our graph here. So put that on your graph, and as you can see, I graphed my 3 graphs. I did my sine x here, the solid one, and I did the 2x in the blue, and then I did the 3x, sine 3x up this side. 3 sine x up there on the same axis, okay? Again, so kind of like what you notice that, if you notice about the amplitude, we have a few things that happen here. So we're going to talk about what it looks like in standard form and what's happening. So let's do that. Okay, so let's talk about the amplitude in standard form. So what that looks like is that's going to be y equals, and then our A, which is our amplitude, sine x. So hopefully you notice that what the amplitude is doing, okay, kind of stretches our, hopefully it stretches that you see that it stretches up. So the A is, okay, the amplitude. Okay, and it represents a vertical stretch. Okay, all right. And I kind of want to define what it describes. So this actually, the amplitude, it describes, I'm going to write this on here. It describes, the height of the graph, both above and below a horizontal line so that's kind of important, it's a horizontal line passing through the, and I kind of like want to put this in quotes, middle of the graph. So if you notice here, if you go back up, that the amplitude, when it's talking about above and below, were the height of the part. And so we talk about, this is called for us, this thing that's in between here. This is where it's like halfway. And if you notice that from here to here has to be the same height from here to here. And that's what it's talking about. That's the amplitude. That's your A. Okay. And it happens, and it should be the same thing. Okay, and so this little line I drew here that I'm highlighting in green here, that's what we're called. That's that horizontal line that that's in that little information we gave below. And so that little line, that horizontal line, okay, it's a horizontal line, and we call that the midline. Okay, and the midline, I'm going to define it here. Oops. Sorry, I'm the wrong thing. Okay, so that's the midline. Okay, the midline cuts, in a sense, the graph in half. The max and min will have the same height. Okay. And when we talk about the amplitude is distance, okay? Amplitude is distance. And it's the distance, like you said before, it's the height. It's the distance between the midline and the max and the min. So like for this right here, for this one, this is a midline. I mean, from the midline from here to here is 2, okay? And that is a distance thing. So I want you to understand that the amplitude is distance. So it's positive. Okay. All right. So I'm going to do a little bit more information, and I want to move up here so to the top and put it up here. So we talk about the amplitude. So kind of help us in other ways to find it. So hopefully you saw that it's halfway between. So that amplitude tells you how high and how low to go. And so that's going to help us to draw the graphs, understand how we know what that A is. Okay. And so there's a couple ways that you can find the amplitude that'll help you. Okay, sometimes we can just visually see it. And if you're not too sure, because it's not always going to be nice and pretty, you know, life's not always like that. It's not going to be always right there on that x-axis. We're going to move around. And so we want to make sure that we know what it is to write the correct equation. So one of the things we can talk about is the amplitude. Okay, the amplitude equals half the vertical distance. And there's that distance I was talking about. It is positive, okay? Distance is not a negative thing. From the max or min. Or another way you can think of it, it's the distance from midline to max min. So a couple ways that you can find it, okay? And this one really will help us when we're talking about it's the midline, we start from there. Okay, so we're going to go back to our calculator and we're going to graph these two on our calculator. And so one of them is already in there. So I'm just going to delete everything else and then put in the -2 sine x, okay? So go ahead and do that. Okay, so I have these in there. The window stays the same, so you shouldn't have changed this part at all, okay? So this part right here should not have changed, okay? And then when you graph, you're going to see both of them on there, okay? So if you, I'm going to go ahead and take one of them off so we can make sure we have the right one that we're looking at. So if you did both of them, just hit enter, and it'll take that highlighted area off, and then hit enter. So we're going to do this graph first. Okay, we'll graph this one, and then we'll graph the second one. Okay, so go ahead and graph that. When you graph, make sure that you remember to always label your axis. And you always label like this for now. Every time we do this, this is how you're going to do that. So make sure that you are labeling pi over 2. Okay. Pi. And then 3 pi over 2. And then 2 pi. So you're probably going to hear me say this a lot because before we would count by ones like we normally would graph, but here we're not counting by ones. We're counting by pi over 2. So this first one is 1 pi over 2. We don't really need the 1. The second one would be a 2 pi over 2 because we're counting by pi over 2. But this cancels to give us a pi. Next one is 3 pi over 2, and that doesn't change. And the last one is 4 pi over 2. Divide that out, and you get 2 pi. So that's what's happening every single time. So we're also thinking about all the quadrants of the unit circle. That's what this is. We're going all the way around. But just to get kind of used to talking about counting, okay? All right, so when we graph this one, we know it went up to 2. So label the side. We have 1, 2, 1, oops, -1, -2, okay? And then when we count, get rid of all these. So when we count or plot the points, we're going to plot just like we've done before, okay? We have, when it's sine, we have sine of 0, 0. And then this one's pi over 2. But our midline is what's here. And our midline, that's that line that goes there. Our midline has an equation, that's y equals 0. So for now, we'll be talking about what that is. Now from here, when we talk about the midline, we're going to go up 2. Because from the midline, we're going up 2. That's what the amplitude, that's what this A is. Your A is 2 here. So it's telling you from top, from your midline, you're going to go up 2 and down 2. Well, at pi over 2 before on our sine, when it's our parent function, we go to 1. But since I have to go to the amplitude of 2, I have to have this one to go up at 2. I come down the midline, and now I got to go down here to -2 and go back to the midline. Okay? And so when I draw my graph, and I want your graphs to be nice and pretty as best you can. iPad's kind of harder to at times. It seems like, I guess it's going to take a lot of practice doing it, but it's definitely easier on paper, I believe. But anyway, so when you do this, your amplitude is here. Your amplitude from here to here is a 2. And that's what that A stands for. Same thing here. Amplitude from here to here is a 2. It has to be the same, top and bottom, high, min to max. And it's from the midline. So that's why we kind of want to know what the midline is. Okay. I'm going to talk about domain. So our domain here is 0 to 2 pi. Your range is now, instead of -1 from the parent function, it's -2 to 2. We always want to talk about domain, range, all those things. Okay. So now if you saw earlier, let's go look at our calculator. If you saw earlier when we graphed it, we went to, pull this up a little bit. I'm going to go to my y equals. I'm going to go ahead and take this off so you can just see this one. Enter, and then I hit graph. So now if we notice, we flips. And we really probably did not need this because you know that negative means reflection, all right? So let's go back to our graph. And we think about what we're graphing here. We're graphing y equals negative sine 2x. So plot your points. Again, everything should be pi over 2. Pi, 3 pi over 2, and 2 pi. Now, this is going from -1, here's a -2, up to negative positive 1 and 2. Okay, so we have our midline. It has not changed. The midline is still here across this axis here. Okay, so now what we want to look at is we're going to graph this function. Okay, so if we know it, by looking at this one, we're going to flip over. So we know we have to go here to, it starts there, but we have to go down to -2 because we're flipping over. And we're going to go to pi, and then we'll go to +2, and then we'll flip it over. It should look like our graph. Like how the graph is nice and smooth. It doesn't look like parabolas. If you think about, this is the circle that's being cut up into 4 parts and moved around. So again, I apologize for the crudeness of this. I'm going to do that. So when you draw a graph, just kind of make sure that you try best you can to make it nice and smooth. Again, it's not a parabolas connected together. Okay, so let's talk about the amplitude here. Okay, again, the amplitude is the same. It does not change. Okay, this is still A, and it's still a 2. From here to here is 2. It's not a -2, it's 2. So when we talk about the amplitude, we're going to say the amplitude is 2, but it has a reflection, and it reflects across the x-axis. We know that from just doing straight graphs, parent transformations, the entire time we've been doing this whole, since probably you've been Algebra 1 for y'all, maybe even sooner. But it reflects over the x-axis because we know what that that negative means to us. That negative means something. And you didn't have to say, well, you know anything about a sine graph to know what it does. Okay, let's state our domain and range. So our domain is 0 to 2 pi. Range is a -2 to 2. It has not changed from the other one. Okay, so let's fill out this little box down here. It says in standard form, when y equals a sine x, when the a is negative, the graph, and again we know this, reflects across the x-axis. Again, we know that from all of our graphing we've done in transformations. So keep all that in mind. It's still the same. We're going to go on the next page. You don't need your calculator anymore, so go ahead and put that away. We're going to start graphing without. Okay, so now we're going to graph y equals 3 sine x and y equals -3 sine x. So again, without a calculator, we know that we're going to always label our x-axis as pi over 2 because we are counting by pi's over 2. So hopefully you remember we're counting by pi over 2. Okay, so that's that. And then we're going by ones. So give yourself some room to do to figure out how it goes. So sometimes we might have to go off the graph, but right now we're going to go by ones for 1, 2, 3, and -1, -2, and -3. And don't forget that this is 0 up there. Hold on, my 3 looks kind of funny. -2, -3. And so this is 0. Sometimes we forget that's fine. That's what we need there. Okay, so we have a midline. We're not moving from this part right here like we're not, you'll see in the next few lessons when we change a little bit. So our midline is y equals 0. It's for this graph, it'll be for all these graphs right now. So put that over there for sake of doing it. So now I'm going to amplitude. So I know I'm going to start. So here's my midline. So I know I have to go from 3. And this sometimes helps too, is to do this on the axis. It might help you to see how high you go and how low. It just depends. And it's not a reflection. So we know A is 3. There's no reflection. So we know at our highest point, we have to be 3 from the midline and down to a 3 from our midline as well. So the first thing we're going to do is we start at 0. We're going to go up to 3. Then we're going to go down to the midline, go down to -3, go to the midline. Notice that you're going to the midline. And so we're going to go up here. Try to draw a nice pretty graph. Okay, then again, here's our A. We're going from here to here. Our highest point is 3. So that's your A. Okay. For this one, for both, the domain is going to be 0 to 2 pi, because you can see what we're doing every time. Now the range for both, for this one, is going to be, that we see so far, -3 to 3. And this should be the same because we haven't done anything. We're not moving anywhere. So the thing with this one, we're going to be having reflection. So we know A equals 3, but it reflects. Again, I don't want you to put A equals -3. I don't want you to be confused with and confusing yourself that because there's a negative there, that means A is negative. A is not negative. A is distance. So just kind of write yourself a note. Anything over here to remind you that this is your negative part, okay? So again, label your graph. Always going to label at least 4 of these marks, and you'll show when we start doing more how many you need to do. So we're going to go up 1, 2, 3. And we're going to, there's a 0, and there's a down -1, -2, -3. Since it's a reflection, we are going to start going down. So start at the midline, but down this way we have to go 3 because of the amplitude. Go back to the midline, go up to the 3, and then go down to the midline. You need to know your parent function for the sine, cosine. We'll get into tangent and all those other ones, but for what we're doing so far for this unit, you need to know your parent function, what they look like. So again, our amplitude is here. All the way up to there, it's a 3. From here to here, it's a 3. Our midline is y equals 0. This is midline for both. And this is the domain range for this as well. They both have the same domain range. Just because of reflection doesn't mean it changes that. Okay. I want you to graph the next one on your own and check with me in just a second. Okay, just real quick, this is what your graph should look like. I forgot to tell you, make sure you state the domain range. Make sure you tell me what the midline is. And again, you see this is this little smaller. I labeled by halves instead of doing 1, 2, 3 because I thought it'd be easier to see. Okay, so graph the next one. So I'm just kind of, I've labeled everything on my graph. I'm just going to kind of walk through this one with you to make sure that you're doing fine with it. So on this one, the reflection will be, it'll be a reflection. So again, we still start at the midline. Oops, I forgot to label that as a 0 here. And this is our midline. Don't forget, we have a midline right here. Okay, that's y equals 0. And so with that being there, we know that we're going to have to go up a half and down a half. So when we do a reflection, we are over here. We reflect down here. It's a -1/2. Go up to the midline at pi. 3 pi over 2 is at +1/2. And then 2 pi over it's the midline. And you stop there. So then you're going to graph your nice little... I always seem to have to do that last part. Sometimes the upside down kind of gets easier. Okay. Again, same thing, half, half. Domain and range are the same thing as the other one, and the midline's the same. Okay. All right, so let's go look at the cosine graph and kind of remember how to practice that one. This is the next one we have here. Okay, so remember the cosine starts on the x-axis. Okay, so we have a cosine x and a y equals 2 cosine x. All right, so cosine x, we have, again, let's label our parts on the... And we do this a while with the parent function that we count by halves, pi over 2, so that you can get used to it and feel comfortable graphing. Okay, so let's make sure we have our parent function, 1, 2, 1, -1, -2, and here we have 0. Okay, so we know at cosine x, we know that we start at 1, okay, and then we come down to pi over 2, and we do -1, come back to the midline at 3 pi over 2, and then go back to 1. And so the cosine parent function looks a little, to me sometimes when I draw, I feel like it's incomplete, okay? Because it feels like with the sine, you get to like go up and down like you can visually see it. But our amplitude is 1, okay? Amplitude is 1. And when you do a cosine graph to check, because this is our midline, it cuts y equals 0. And if you, what it does is you have to go to the end where it's at. So this is where the 1 comes from. This is your 1 here, but it's also the amplitude talking about here. You can look at here and make sure you're going up and down 1. Okay. Domain is still domain and range for parent functions of sine and cosine are the same. So it's from 0 to 2 pi. And our range is -1 to 1. And that's for the sine graph as well. Okay. So let's do this graph with you. Label this pi over 2, pi, 3 pi over 2, and then 2 pi. We're going to go by 1, 2, -1, -2. Now we graphed this earlier, this cosine graph, but that's okay. We did a sine, sorry. We did not do cosine yet. Okay, so what we're going to do is we're going to start at 1. Our amplitude is different on here because now we have to start 2. A is 2. Okay, so if this is our midline again, y equals 0. That's the midline. And then you want to make sure that you go 2 from the midline. Well, we start at 0, we go up to 2. We're on the axis. Okay, then we come down, we cross at the midline, pi over 2, go down to the -2, come back up to 3 pi over 2, and then 2 pi. I like to draw my points because it's easier for me to see what I'm doing, and then I can draw the graph. And again, I'm just kind of make sure you understand where the cosine, where you see the actual height of it. Okay, so if the amplitude is 2, here's a maximum here, and this is a maximum as well. Okay, so this would be 2, this has to be 2, and then this is also 2. So we know that's 2. Domain range, so domain is still 0 to 2 pi. And our range, though, is -2 to 2. How low does it go from here to how high? Okay, I'd like you to graph the next one on your own and check the next 2, and I'll come back and check to see how you're doing. Okay, so as you see here, I did my graph. I have this one, we have the curve going this way because it's a reflection. It's got the amplitude of 2, remember that? And then this one over here, it's got, it has an amplitude of 1/2, and I write that down, but it has a 1/2, as you can see, from pi to up to the max. It goes up 1/2, and then you over here to the min on each side. Okay, so it's a little bit different with what you look at on the cosine graph. Over here now we have the domain, which is 0 to 2 pi. Range is -1/2 to 1/2. And our midline y equals 0. Okay, that's 7.2.